So in exercise 3-1, you guys plotted some different graphs. So now we're gonna take a closer look at some of these graphs and see what their equations say about like the different graphs features. So the first thing that you should have noticed is one, that the graphs are all straight lines. And the reason that is because they're linear functions. Meaning they're first degree polynomial. And those are all going to be straight lines. Now, the second thing you should notice is the value of m, or the slope, like determines how tilted the graph is going to be. Determines tilt. So basically what that means is as m gets bigger, becomes positive, then the graph slopes up, which means it's more tilted. So it would look something more like that. Whereas if m becomes more negative, the graph tilts down. So it would look something like that. And also, if m is 0, then it is a constant function, meaning it's a horizontal line. So, and finally, the third thing that you should notice is the value of b determines the y-intercept. So now, let's look at the equation y equal, whoops, we're going to look at the equation y equals 3x plus 7. Now, if we set x equal to 0 here, we're going to get the equation just y, we're going to solve for y then and get y equals 7. Now, this is going to be the y-intercept because that is where the x-coordinate is equal to 0. So if we were to plot this point on the graph, it would have a point at 0, 7. So this leads to the definition of the y-intercept, and that is it is the value of y when x equals 0. And conversely, the x-intercept is going to be the value of x when y equals 0. So finding the x-intercept here, we can set y equal to 0 and solve for x. So we'll have 0 equals 3x plus 7. Negative 7 equals 3x. And x equals negative 7 thirds. So when y is equal to 0, x is going to be negative 7 thirds, which is going to be somewhere right here. And the graph will look something like this. Whoops, that's not very good. Like this. So another property of linear functions is the slope. Now, the definition of the slope is going to be the ratio of rise over run. So if we're going to have rise over run here. Now, what that means is that if you start at any point on the graph and you run along in the positive direction, and then you go up or down, that ratio of the amount you went to the right and the amount you went up or down is going to be the slope. So if we're looking at like any particular graph, and we're just going to say it's a linear function, it looks something like that. And we're going to start at this point and this point. So the graph is going to change in the y direction. It's going to rise by that much between those 2 points and move over by this much. So we're just going to call this y and this x. So then the slope here, m, is going to be the change in y, the rise here, over the horizontal change in x. So y over x. So this value is going to be a constant, no matter which 2 points you pick. So this property about linear functions is actually provable from geometry with the definition of similar triangles. So let's say we have a graph that looks something like this, and let's see, we'll say it's a linear function that looks something like that. So if you pick, let's say, 2 points right here and right here, we're going to call this the run and this the rise. Now, we can pick any 2 new points and call this the run and this the rise. Now, these triangles that we just made right here are similar triangles. So that means that the ratio between these two sides is going to be a constant. So the rise over run equals a constant. Now the reason that they're similar triangles, remember, is because this is, we're going to say, is a right angle right here. And because this is a linear function, the angles right here are also going to be equal. So for that reason, they're similar, and that makes the rise over run a constant. So this leads us to the definition of slope, which is going to be that slope equals the ratio of rise over run, where the run is going to be the horizontal distance between 2 points on a graph, where the rise is going to be the vertical distance between 2 points on a graph. So let's say that we have the 2 points on the graph x1, y1, and x2, y2. So the rise here then is going to be the distance between these vertical points, which is going to be y2 minus y1, or change in y. Now this symbol, the little triangle, is called delta, so it's going to be delta y, which means the change in the y, where the run is going to equal the change in the distance between the two x points, the horizontal distance, which is x2 minus x1, which equals delta x. So then this leads us to the new slope formula. When we have these 2 points, x1, y1, and x2, y2, the slope is going to equal y2 minus y1 over x2 minus x1, which equals delta y over delta x, or the change in the vertical points versus over the change in the horizontal points. So it turns out that if we have the formula y equals mx plus b, which is the general formula for a linear function, it turns out that m is going to equal the slope. Now we can prove that using, let's say we're going to let x1, y1, and x2, y2 be 2 points on the graph. So From that, we can substitute these 2 points into the original equation. We're going to actually end up writing 2 equations. First, for this point, since both these points are on the graph, we can say that y1 equals m times x1 plus b, and y2 is going to equal m times x2 plus b. So now we can, if we're going to subtract one equation from the other, we're going to get y1 minus y2 equals mx1. It's going to be mx1 plus b minus mx2 minus b. So the b's are actually going to cancel out since we're subtracting. So it's really just going to be m times x1 minus m times x2. From there, we have a common factor right here. We can factor out the m and say that y1 minus y2 equals m times x1 minus x2. Then solving for m, we will get m equals y1 minus y2 over x1 minus x2, which is the change in y delta y over the change in x delta x. Whoops. So these past definitions lead us to the general form of a linear function, which in this form is called slope-intercept form, and that is if y equals mx plus b, then m is going to represent the slope of the linear function, and b is going to represent the y-intercept. So with that information, we can actually draw the graphs of different linear functions without making an entire table of points. So we're going to now draw the graph of y equals 2/3 x plus 4. So let's start off by drawing our axes. That's not very good. So we're going to start off by drawing our axes. Whoops. Okay. So we'll start off by drawing our axes. Okay, there we go. And then we're going to indicate which axis is going to be the x and which one is going to be the y. You're always going to want to do that. Then at this point, we know that since this is the b term, we know, remember the general form y equals mx plus b. The y-intercept is going to be 4, so we can count up 4 units. 1, 2, 3, 4. Normally you do this on graph paper, but it'll work just the same. From there, we know that the slope is going to be 2/3. So a good way to remember if it's going to be sloping up or down 2/3 is that since the slope is positive, it's going to be increasing, tilted up from left to right, whereas if it were negative, it would be decreasing, tilted down from left to right. But it's positive. So from there, we're going to count from this point 2 units to 3 units to the right, so count 1, 2, 3, and then 2 units up, 1, 2. So the next point would be plotted right here. And then counting in the negative direction, we're going to be counting 2 units down, 1, 2, and 3 units to the left, 1, 2, 3. So it's going to be right here. Then we can just connect these points. Whoops. At this point, we're going to want to indicate a scale, because, and remember that we counted by 1 in both the positive and negative directions, so we're just going to indicate that right here that is representing 1 unit on both the x and y axis. So now we have the equation 5x plus 7y equals 14, and we want to get that into the form y equals mx plus b, because then we'll know exactly what the slope is and the y-intercept, which we need to graph. So to do that, we need to solve for y. So to start, we need to move the 5x over. So we'll have 7y equals negative 5x plus 14. Then dividing by 7, we'll have y equals negative 5/7 x plus 2. From there, we can draw our graph. So we'll start by drawing the horizontal and vertical axes and labeling them x and y respectively. Then we want to start again with the y-intercept, so we're going to count 2 units up, count right here. Then, now this one is going to be sloping down because the slope is negative, so from left to right the graph is going to be decreasing. So we're going to count 5 units down and then 7 units to the right. So here's 1, 2, 3, 4, 5. Then 7 units to the right is 1, 2, 3, 4, 5, 6, 7. So the next point is going to be right here. And a point on the other side, we can count 5 units up and then 7 units to the left. So we'll count 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. So this point is going to be right up here. At that point, we can just connect these 3 points, and we'll have a graph. I recommend using a straight edge of some sort, so the graph doesn't look as atrocious as this, but you get the idea. So for this final example, we're going to start with the equation x equals 6. Now, for this equation would technically have the form x plus 0y is equal to 6. Then transforming that into the equation y equals mx plus b, we need to solve for y. So we're going to have 0y equals negative x plus 6, at which point we would divide by 0 and get y equals negative 1 over 0 x plus 6. Now, the quantity is negative 1 over 0 and 6 over 0. Those are going to be infinite. Whoops, this should be 6 over 0. These are going to be infinite quantities, meaning that they're larger than any real number because they're not real numbers. So that means that there really is no slope and no y-intercept. But the graph is still pretty easy to draw because basically we know that the equation is x equals 6. So for any value of y that you substitute into that, x is always going to be 6. So drawing that graph, we would start counting 6 units. 1, 2, 3, 4, 5, 6. And our graph would just be right here. It would be a vertical line. Now, this line is not a function because for every value of x, which is 6, there is an infinite number of values of y. So we'll indicate our scale, which is 1 here, and label the axes now, x and y. So let's say the equation from the last problem had been y equals 7. Then this graph would be a horizontal line instead of a vertical at y equals 7. So this leads us to the definition of the horizontal and vertical lines. So that basically if y equals a constant, then the graph is going to be a horizontal straight line at the constant, and the slope is going to be 0. And so it's going to be a horizontal line. And if x equals a constant, as we saw in the previous problem, then it's going to be a vertical straight line. And the slope is, there's going to be no slope for this. The slope is going to be undefined. And it is going to be a vertical line at that x constant.